Okay, this is how we can solve these problems and apply them. I'm not going to do every single question you see here, but I will whiz through them quite quickly. So if I wanted angle A is on a chord at the bottom here. So if I create the bottom in, angles in the same segment on this chord, so the 59 is the same as the A, so A equals 59 degrees. If I was to draw in the other chord for 28, I know 28, drawing the chord across there. Angles in the same segment, B is 28 degrees. In the same segment are equal. And all parts of that statement are needed. So we will talk about angles, same segment are equal. If you're asked to describe, you should show those. Same thing goes on for question 2. Question 4 is a double angle one. So go back to my usual purple. There's the chord along the bottom. This is the construction we started with. And the angle at the centre is double the angle on the circumference. So half of this is going to be 39 degrees. So angle at centre is double the angle on the circumference. Okay. That even applies here. I know these lines look like they cross over, it looks like there's a big problem, but it still works. So if I draw in the line going across, this 44 is the same as an angle up here by angles in the same segment. And if I complete that diagram, we now get the classic double angle one. So I is 88 degrees. Okay, so it doesn't matter what, as long as it's anywhere above the chord or on this side of the chord, and it's these two being in the same area compared to the chord. 2 others, and I want to do this one and this one for this segment theorem. So if I was to draw in a chord across the circle, opposite angles in opposite segments, also called cyclic quadrilaterals. This is often called a cyclic quadrilateral. Are supplementary or make 180 degrees. So with the purple one, C must be 105. If I was to draw the one going the other way, D must have been 95. To make opposite segments make 180. Quadrilateral makes 360. Funny version of this, I'm only going to do E on this one. But if I do E on this one, there's a sort of half fact here, which is similar to a half fact you get in triangles. And this is the external angle of a cyclic quadrilateral is actually equal to the angle in the other segment. And it just follows from actually going, what's the angle required on the other side? 71 degrees. Therefore, the opposite angle must be 109 degrees. Final couple of diagrams. Oh, some that were missed were diagrams where you get a definite right angle, which is why I want to do question 6. First one, question 5. Centre's in the middle. Alternate angles, so there's the chord and there's the tangent. They create a segment, so I is equal to the 37. So angle between the chord and tangent equal the alternate segment. I'm not sure why they call it the alternate segment. But I'd have called it probably the apex, but that would be the way I'd write it. Quickly do this one as well, same idea. Angles in alternates sorry, no, that's the same as one of these, that's easy. This one, we can do this 29 by alternate segment theorem. And the other one we've got here is this double angle one with a straight line going through the centre. So that's actually 180 degrees. And the chord is that one. And the angle in the opposite on the circumference is 90 degrees. And that's a variation of the first examples. So therefore I can now work out this angle as being everything up to add it up to 180, 90, so that's going to be 61 degrees. So this is how I can use those angle facts to fill in all of those examples.